Hello there everyone, hope you're all doing well. Welcome back to another self-study lesson, which is exercise 15, and this is radio navigation. Now this is something quite different to what you're probably used to, as we're actually going to use some instruments that are potentially equipped in your aircraft, depending what aircraft you're using and what instruments it has in it. But it's quite different because we're actually going to be focusing on how we use those instruments and kind of focus on kind of leaning into an instrument rating type a lesson in a way, but of course we're only using this to further your knowledge of how to maybe use these instruments to assist you in your navigation. Firstly, why would we use this? I mean, the aim of this lesson here we see is to learn to use the radio navigate for tracking. So why would we use this? What's relevant for this on you, to you as a VFR pilot? Well, if you're on a long navigation and you've got a long leg, there's not many feature points along the route, and you can't really tell whether you're on track or off track or on time, etc. Then using if that leg at some point has got a VOR or an NDB towards it, then at least you know you're on the right track. Now, the chances are, I mean, these are being faded out, so the chances are VORs and that along your route around the London TMA area, for example, might be quite slim, just due to airspace, and you won't be able to track a direct line. However, it's a very useful aid for if you're heading up towards, say, Scotland or towards Manchester area where there's a bit less airspace to contend with. So, VORs, firstly, what is it? A VOR, an NDB, is a ground-based navigational aid. They don't move. Of course, your aircraft moves around them. So what that means for us is there are certain distances and certain positions that might affect whether you actually pick up the VOR or NDB signal. This is all way too much information for your knowledge, but just to give you a background, if you're in London and you're trying to pick up the Tala VOR up in Scotland, you're not going to pick it up because it's miles away. The curvature of the Earth, these work off line of sight. Okay, these are a bit like your radio's line of sight in respect to an air traffic controller and yourself. That beam through between your aircraft to a ground station. If there's a mountain in the way, you're probably not going to hear them. So VORs, firstly, there's an acronym we use to identify and be able to display or know that we're using the right VOR. So what that is here, as you see, prior to tracking, we need to do SID. SID the sloth, however you want to remember it. SID for departure, instrument departure, whatever. So SID, S for select. So what that means is we're going to select a VOR. So that any VOR that's in the location or you're around your area that you want to track towards, you select that and you find the frequency for it. So I don't know, let's say it's 114.55. So we've selected that, we've put that into the radio. We need to identify that. Now it depends on what radio you've got, whether it's a modern one or an older radio. How you identify it differs very slightly. However, what we need to do is turn the squelch up for that frequency to listen to, very old school I know, the Morse code. So the Morse code is printed on your charts or on little nav map or whatever else you're using. It is printed on there and it will show you exactly what the Morse code is. Now we could choose any frequency, plug it in, and we'll get a reception off. Potentially get a reception off the receiver. However, we don't know that's the correct one. So if you started tracking an incorrect one without identifying it, now you're charging through Heathrow's airspace and you've got a lot of angry controllers. And other aircraft as well. So identifying by choosing the correct frequency, putting it in the radio, turning the squelch and volume up to identify the Morse code. It will play every 15 to 30 seconds, it depends. I mean, I've had a bit of everything, to be honest, so normally it's like every 15 to 30 seconds where you'll get the Morse code identify, and you need to just listen to it. It's just dashes and dots. If none of you know what, if any of you don't know what a Morse code is, dashes and dots, and that's going to identify against what you're reading on the map. if that matches up, then we've identified that beacon correctly. So now we need to display it, and that comes on to this. So we have this instrument, and you might have a bit more of a developed instrument than this one. It all depends, again, what your aircraft's equipped with. But this is your CDI, effectively. Or an OBS. It depends. I mean, people call them different things, but there's more developed versions of this. But this is sort of a basic one that you would get in older aircraft like a Cessna 152, etc. So how we would display it? Well, we need to kind of go into the theory of it. So here's the first image. So this green shape shows your aircraft. That's the back of it, that's the front of it. So the pointy end is the nose of the aircraft. And this here, the diamond, is a VOR. Now if we're tracking towards this, 360 is north, okay? So let's say we're north facing up on, this is a top-down map, we're facing as per you would on, north up. So the aircraft is to the north of the beacon, hence the 360 radial. Now what a radial is, if nobody knows what it is the beacon transmits 1 degree radials out. So imagine this like massive pizza, and someone's gone ridiculously crazy and done loads and loads and loads and loads of little slices. So you've got 001, 002, 003 and so on. Okay, so if we displayed all the lines here, there'd be too many lines to comprehend. So what this means is we're on the north radial, the 360 degree radial. It's shooting out a line continuously till it can't shoot it anymore to the north. We're on that line, but we're tracking southbound, so we're now going towards the beacon. How that displays for us is we've got a to and from flag. That's how we know if we're going to a beacon or away from it. So at the moment, the to is shaded, so that's showing we're going towards it. Now, as it says here, to find track, you need to first get the VOR, and then you can twist the OBS to center the CDI. So effectively, you're twisting this needle in a way, obviously not on this ADF, but you're twisting this knob to change the degrees at the top until the line centers. Now it moves like so. So it will move across in towards a center. You're just twisting it until you've got it centered on the dash line. So now we've got that centered, we know that we're going towards it because we've got a to flag, and the line is centered, so we know there'll be a little arrow at the top and the number, so we know we're going on towards it on a radial of 180, or a track, shall we say, of 180. Same. When you do twist this around, if you go through 180 degrees, it will highlight the from flag. Now it depends if you want to know what way you're going or what direction you want to go. So say I wanted to go away from the beacon, I would set it until it says from. The from flag is highlighted and the line is centered. If I want to go to it, I'd set it up as this. I'd twist the knob until the whole thing rotates and the to flag highlights, and then I center the line. So once the line's centered and the to flags highlighted, I know that now I've done what I've set up or displayed what I wanted to achieve. I wanted to go to the beacon and center it up from where I am now. So we've just got lucky, we're directly north of it. So this is great, but there's some little bits with it. So this line is a fixed line. Think of it like a train track. It's a fixed line across the ground / in the air. The wind doesn't affect the line. The wind affects you, of course it does, as you know from navigation. So if there's a still wind, no wind at all, we could track it on a heading of 180 degrees, and we would follow this line almost perfectly until we get towards the beacon. Now, let's say we've got a wind from the left. If we've tracked 180 the whole way, over time we would position or drift off to the right of our track line, because the wind's going to be coming from where my mouse is now. It's going to be coming from the left of us, so from the right, from here to the left side of our aircraft. So what we need to do is we'd need to adjust our track or our heading to maintain the track. Now, of course, that all depends on the wind speed and the angle or direction it's coming from relative to you. That's not what we're going to get into today, but you need to just be aware that to track, just like your navigational, your NavXs, if you go draw a line from A to B, if you fly that with a wind, but you fly that track number, you're going to drift off it, of course. So same thing applies here. So let's say we have drifted off to the right of the track that we wanted to be on due to the wind. This is how it would look. So the centered line is what you wanted. Now this line is the actual line or radial you were trying to achieve. So now that's drifted off. We were going on a heading of south, correct? Bearing in mind we're saying, say there's no wind. We were going on a heading of south, but the line's now to the left of us. So what that means is it's moved in this direction from center to the left. So that means the dotted line is effectively where you are, if you want to think of it like that. The line, or the radial you want to achieve, is now left of you. So we'd have to position ourselves towards the line, position a heading towards the line in a left direction, and be able to track it in. Now, as you do that, it will come back in. So as you move the heading to the left towards the line, let's say a heading of 140 degrees in this case, we've done that, and now, over time, the line will come back centered, and then that's where, if we had no wind, we would switch back to a heading of south to track back towards a beacon. Now, let's look at another situation. We are here. This is us, this green tick again. We're heading away from the beacon in a northwesterly direction. So let's say a heading of about 300 degrees, maybe 290. If we wanted to see how that looked like and displayed on our on our OBS, then we want, let's say we've set 2 and a line to the left of us. We're tracking away, and we now know that the 360 radial, which is still this one, it will still show to the left. The reason being is because even though that radial line is actually on your right hand side, all this doesn't know what your heading is. This just tells you if you want to go south towards it, we've got the 2 flag highlighted, then the line, the radial line, is going to be on your left. Because, like I said, you've set it so the line cuts through you like this. So the instrument only thinks, well, where you are, the line's to the left of you. So this dotted line is where you are, irrespective of heading, the line's to the left of you. I hope that kind of makes sense, and we can try and replicate this a little bit later on. But the biggest thing to remember is the instrument doesn't care what heading you're on. If you're heading north, then this would still show to the left of you. Does that make sense? Right, so coming on to the next one. Radials. Effectively the same thing, okay? So we're heading away on the northerly radial from the beacon, so we have the from flag highlighted and the lines in the centre. Perfect, that's what we want. You can see that we've got a nice bit of drift on here for wind as well. Let's say we've overcorrected the heading because we haven't really worked out what the heading or drift should be. I've lost my mouse. We've now drifted and corrected way too far to the right. Oh no, well the line's now gone to the left of us. So again, we've got a from flag, and the dotted line is our position. The line, the radial's now gone to the left of us. So that means to get back onto the radial we selected, the 360 degree radial, we need to position our heading less than 360 degrees. So let's say a heading of 340, 330. We can go left, and then that will bring it back to the centre. And again, how do we know which way we're going? We've got the from flag highlighted, so we know this picture here on the instrument, which is only what you're going to see, this is how it looks. The beacon's behind you, you're tracking away from it. So away from. Or if you want to go to, you're tracking to it, okay? Now, I know it might sound a bit like I'm sort of teaching you how to suck eggs, but at the end of the day, it can be quite confusing because there's a lot going on. And I've had it with a lot of students in real life where they're like, well, yeah, I've got a 2 flag identified, so I'm going away from it. So yeah, you're going to it, you've got a 2 flag. You're going away from the beacon, you want the from flag identified. Right, another example. Let's say we're going back to the initial example that we set. We're on the 360 going down to the beacon. Over top of the beacon, let me start with this. The closer you get to the beacon, the more sensitive it becomes. Now, it's hard for me to kind of show this. However, if you think that this is the beacon and the lines go for miles and miles, hundreds of miles out and out, every line is going to get further and further away from each other. Okay? So, as you see, if I imaginary draw a line from where my mouse is through the 45-degree here, if you're near the beacon, this distance might be 50 foot between the line. If you're out here, 50 miles, then this distance could be, let's say, 50 miles, because obviously the line is further away from the dash line here. So I hope that kind of makes sense. So the closer you're getting to the beacon, the more sensitive the needle becomes, because the distance between each line is a lot smaller, or the distance between each radial, should I say, is a lot smaller as you get closer to the beacon. So if you're 50 miles away, to get this change back on the instrument might take you 5 miles to gain that back. As you get close to the beacon, this might only be a matter of a mile or half a mile to get that 10 degrees back. So I hope that kind of makes sense. Once you get overhead the beacon doesn't know what the hell's going on, and the instrument doesn't know what's going on either. So you get this cone of confusion. So the cone of confusion is effectively an area or a grey area. So you might get some spurious indications on here, or you might get a false indication saying that you're now flying left of the line. Well, you're not. The biggest thing is, once you're getting over it, you'll get the to and from flag probably flicker, or you might even just lose the flag highlight, so it won't know if you're doing to or from, and the line might stay in the middle. It might go left or right. This may flash, this may move left and right. So the biggest thing is, when you get those indications, fly what you're doing. So whatever you were doing first, continue flying that, because you're over the top of the beacon or the VOR in the cone of confusion. So at one point you will come out the other side of it and it will all make sense again. So in this case here, we're now past the cone of confusion. We're tracking away from the beacon. As you pass over the top, you're now no longer going to it, you're going from it. So the flag changes to from, and the picture stays the same. We've still got 180 heading south going away. Now again, currently quite close to it, the beacon, so as we drift off due to wind or our inaccurate flying of heading, the line will continuously change and be quite sensitive. But as we go miles and miles and miles away, of course, this is going to be pretty central, and for you to be able to get this to move, you're going to have to fly a good few miles off track. So now come on to NDBs. NDBs are definitely being phased out. We rarely use them. There's a few instrument approaches that have them around the world, but they're just not accurate at all. So again, I'm not going to go into too much detail about NDBs. You just need to be able to track towards these. And same with the VORs. You just need to be able to track towards them. So you get a fixed compass card, so it doesn't move, it just shows you the degrees to be able to work this out. Or you do get a moving compass card where you can actually set your aircraft heading and then work out what you need to be flying to get towards a point, effectively. Let's talk about this. So an NDB, you use the same thing, SID, select, identify, display it, and then when we track towards it on a fixed compass card, this is how it would look. So let's say we're flying on a heading of north. This will make sense. But if we're flying on a heading of south, this is exactly how the instrument's going to be shown. So again, a bit like the VOR, when we're flying away from it, it doesn't know what your heading is. That's the same with this. It doesn't know what your heading is, the display. However, the needle is pointing to where that fixed beacon on the ground is. Now, if you said, well, that's a radial of 120, 130, 135, so I need to fly 135 to get there. It's not always the case if you think of it just purely of looking at this going, yeah, okay, well, I need to turn right by that many degrees. Because if you're on a southerly heading, the quickest way is going to be turning left to it by X amount of degrees. So what we talk about, this is only on a fixed compass card. It only shows the relative bearing, so the bearing of the beacon relative to your aircraft position. In this case, it says it's right behind us, so about our 5 o'clock position, 5 o'clock position. So what we need to do is we need to add magnetic heading and relative bearing that equals your QDM. Now, we'll come on to what QDM means and QDR, but effectively these are Q codes, a bit like QNH, QFE, QNE, QSY, whatever else. They all mean something which would have been Morse code back in the day. So QDM, the way to remember which means which is QDM, so a D for direction, M for home. So let's say the beacon we want to go towards is home. We want, because it's a known location, we feel safe going towards that because we're tracking a bearing towards that we know might keep us clear of airspace and terrain. So it's a safe place to go towards. Not always, but let's just use that example. It worked in my head, all right. So QDM is home. Coming down to here, QDR. Well, the arrowhead always points to the beacon, which we said was home. Hence, home has an M in it, so M is the word, or the letter. So QDM is for home. QDR is for from, and the reason being is the tail is going away from it, because we said the head, the arrowhead, is to go towards it. So if that's going towards it, if we want to track this, we need a QDR, and the QDR is from it. So R for from, because from has an R in it. So that's how we've always been taught to remember it, and guess what, it does work well. So that's how you remember what these codes mean and what direction they are. M for the arrowhead to go home towards the beacon, R for the tail to go from the beacon. So let's say, come back to the fixed compass card. In this case, we're on a heading of north, and thankfully that makes our life easy because the display shows north only. So heading of north plus the relative bearing. The bearing is here, and that is from our heading 135 degrees to the right of us. So magnetic heading being either 360 or in this case 000 plus 135 equals QDM of 135. So that means to turn and track the bearing to the NDB, we need to be flying a radial or a bearing of 135 or 135 degrees. Now, of course, this is a bearing and again subject to wind. So once you're on that track, if you had an understanding or worked out where the wind is coming from, you'll be able to work out the drift and what direction or general direction you need to point your aircraft nose either to the right or left of the bearing needle. Let's say, for example, now it's kind of hard to display because it's all the same still, so it will work out in this situation, but let's say we're flying a heading of 330 degrees. So this is how it will look even if we're flying on this heading. So let's say 330 degrees, and we need the let me see, because I wrote it all down, it gets very confusing. 330 degrees, the needle from from here round to here is 135. From 330 degrees round to effectively, actually I've gone wrong already. So from north here round to 135 is 135. From our heading, which is 330, it equals 165 around from our heading. So we do our heading 330 plus 165, that equals 495 degrees. Of course, a rose only goes up to 360, so we need to do 495 minus 360 degrees equals 135. So the bearing would be 135 to head back towards there. Now, in the actual flight demonstration video, we'll show this in different examples, so the bearing won't always be 135, it'll be something else as well. So this is just basically for you guys to know this instrument on a fixed compass card does not move. So the airplane here, the nose is always pointing north, even if you are facing south, or west or east, for example. It's always going to head north. Now, a moving compass card makes it a lot easier because you can change the knob to put your aircraft heading, in this case 324, put in our aircraft heading to it, and now it moves this placard around to show, the QDM is that heading there. We need to fly 010 degrees or 009 degrees track towards the beacon and then adjust for wind other than that. So, hopefully, this has kind of given you a basic understanding of a VOR, the OBS, and NDBs with the compass cards. We will go into the flight demonstration and demonstrate each example, and hopefully that'll be able to come up with a good foundation for you to move on and practice on your own. But if you've got any questions, you know where myself or the other members of the pilot training department team are. So just drop a message in the student chat and any mentor will be happy to answer or clarify any questions from this video. Thanks for listening, guys. Apologies, it's a bit of a challenging subject to talk about, but hopefully the flight demonstration video will make a bit more sense. So let's move on to that.